Oh, okay. That sounds good. That sounds like, huh? All right. So how do we state whether or not an ordered pair is a solution? How do we find if that ordered pair is a solution? What do we do? Just plug it in. Yep. So an ordered pair is always what, comma, what? X, Y. So we're going to plug 2 in for X, 2 in for Y. So we'll get 2 times 2 plus 4 times 2. And we want to know, does it equal 12? What's 2 times 2? 4. 4 times 2? 8. And what's 4 plus 8? 12. Does 12 equal that 12? Yes, it is. Is this a solution? Yes, it is. Okay. What about B? What's going to go in for X in this one? 7. And what's going to go in for Y? 1/2. All right, so what's 2 times 7? 14. What's a half of 4? 2. And what's 14 plus 2? 16. Does 16 equal 12? No, it does not. So is this a solution? No. Okay. So if it's not a solution, does that point lie on that line? Nope. All right, looking at number 2. 3x plus 5y equals 30. And we have the point of 3, 5. So what's going to go in for x? 3. And what's going to go in for y? 5. So 3 times 3? 9. 5 times 5? Does 9 plus 25? What's 9 plus 25? 34. Does that equal my 30? No. So is this a solution? Nope. All right, and B, 10, 0. What's going in for x? 10. What's going in for y? 0. What's 3 times 10? 30. What's 5 times 0? 0. What's 30 plus 0? 30. Does 30 equal 30? Yes. Does this lie on the line? Yes, it does. All right, real quick too. 10, 0. What else is 10 besides an ordered pair? What else would 10, 0 be known as? The x-intercept. Yes. Why? Because it lies on the x-axis. And the y-coordinate is? The y-coordinate is 0. There you go. Awesome. Any questions with that now? All right. So let's go ahead and start with slope. The slope of the line. Does anyone know what letter slope is labeled with? It is M. No, it is M, not X. It is the M. Okay. So the slope M of a non-vertical line. The reason why the slope is non-vertical of a non-vertical line, because vertical lines are not functions. You guys remember that back in middle school? Vertical lines are not functions. What makes something a function? Right, it has to pass that vertical line test. Does a vertical line pass a vertical line test? No, it doesn't, does it? Because every single value of the x is going to be the same, right? So that's why there's no slope of vertical lines. So the slope of a non-vertical line that passes through the 2 points, and my 2 points are x1, comma y1, and x2, comma y2. Okay. Is the ratio of rise over run. Rise is the change in what values? The y. And the run is the change in the x values. Remember, you guys have to rise before you can actually run, right? If I ask you to go run and you're laying down, don't you have to rise before you can actually run? Yeah, so you need to rise before you can run, okay? So the slope is labeled with M, okay? It is, again, the ratio of rise to run. Or we can look at it, it's the change in y over the change in x. This triangle represents change in. what does the change in mean? Like if I know my y coordinates are 10 and 5, what's the change? 5, right? And how'd you do that? You subtract. So you subtract the y values over the subtraction of my x values. And we always write it as y2 minus y1 over x2 minus x1. But guys, it's okay if you actually do y1 minus y2, as long as you do what in the denominator? Take x1 and subtract off x2. Okay. So if you switch the numerators, make sure you switch the denominators. Okay. All right, so let's kind of talk about slope here. Okay. Describing the slope. Describing the slope. And not actually finding it, but we're going to describe it. Describing the slope. Okay. When you guys read a book, which way do you guys read? Left to right, right? So we're going to read a graph from left to right. So if I read this graph left to right, which way is it doing? It is going up, right? And if we're going up, we're going to have a positive slope. So in my case, I could have the slope of 1/2. I could have the slope of what? 2. I can have a slope of 3/4. I can have a slope of 7/2. It just needs to be what? Positive. So if I know my slope is going up, my line is going up from left to right, it has to be a positive slope. Okay. Looking at the second graph, reading that line from left to right, what's happening there? It's going down, and if it's going down, what kind of slope are we going to have? Negative. So we will have a negative slope. Okay. And we kind of look at it like a roller coaster. If you're going up, it's going to be positive. If you're going down, it's going to be negative. So in this case, your slope could be negative 1/2. It could be negative 2. It could be negative 5. It could be negative 6/3. I don't know, something like that, which is the same thing as negative 2. The main thing is, can you have two negatives? Two negatives always make what? A positive. So actually my graph would be going up in that sense, right? Okay. All right. Reading left to right, there's no change, is there? This is a constant, right? Okay. Now, it's a horizontal line. Is that a function? Is a horizontal line a function? Yes, it is. Yes, it is, right? So guess what? You're going to have a slope, right? When you have a constant, a horizontal line, your slope is always going to be, what do you think? 0. My slope is always 0. Okay. Why think about this? Rise over run, right? You rise what? 0, but you run, well, you could run 1, you can run 2, you can run 3, right? You rise 0, and what's 0 divided by anything? 0. Also, I kind of like I have a horizontal line here, kind of like making a V at the end there. Sideways V. What letter shows up? A Z for 0. All right, and then the last one, we have this vertical line. Vertical lines are not functions, right? And if they're not functions, can you have a slope? No. So you could say my slope is undefined, or I also accept there is no slope. Undefined or no slope. Because again, how much do you rise? Can you rise on this line? I can rise from here to here, I could rise. But I run what? 0. I don't go. And can you have 0 in the denominator? No. And so since you can't have 0 in the denominator, that's why it is undefined. Okay. And then this one I kind of make a V off the end. And what letter makes an N for no slope? No slope. Okay. All right, find the slope. Now, if there's a graph, as long as each term is going up by 1, okay, so if I look at my x-axis and my y-axis, if they're going up by 1, I would just count rise over run. So like in number 1, are each of these going up by 1? Are these going by 1s? Yeah, they are, aren't they? From 0, this would be 1. This is 2, right? -1, -2. So I would count rise over 1. What about number 2? Is each one of these going up by 1s? Yes. So again, I would probably count rise over run. And then look at the next one. Number 3. Does each of these go up by 1? No, they're going by 2s, right? So in this one, I would actually have to use my formula. And again, it doesn't matter which way you go. All right. Now, first thing it says, describe my slope, then find the slope. Describing the slope just tells me is it positive, negative, 0, or undefined. So read my graph from left to right. Is this going to be a positive or negative? Okay, read from left to right, Perry. It's going down, so this would be a negative slope, right? All right. Now, when we know it's negative, you can put the negative in the center of the fraction. You could put it in the numerator, or you could put it in the denominator, but you can't put it in both the numerator and denominator, so it does not matter, okay? And then I kind of go from my points that they're given here, and I make a triangle. You can either make your triangle going up, or you could make it going down. Does it matter? No. And then we count from the point. I'm going to rise what? And remember, you can't start counting until you make a move, right? So how many times do I go up? 2. Okay, so that would, if I went up, that's positive. If I would have went down, that would have been our -2, right? And then how much do we go over? How much do we run? 1, 2, 3, 4, and 5. So we have -2/5, -2 over +5, or a +2 over -5. Okay. All right, go ahead and do number 2. Go ahead and do number 2. Okay, reading left to right, is this going to be a positive, negative, 0, or undefined? Bless you. It is a positive slope. Why? Because we're going up. Okay, so since we know it's a positive slope, it doesn't matter. We know positive over positive, right? So from my point, and it doesn't matter, I'm going to make my triangle. How much do I rise? 1, 2, 3, and 4. So I rise 4. And how much do I run? 1, 2, 3, 4, 5, and 6. And now, can I simplify 4 over 6? Yes. And what does 4 over 6 simplify to? 2/3. So my slope is a positive 2/3. Yeah. I could have used this point. But I'm sorry. Did you pick a different point? Yeah, that's fine. Yeah, so we had someone asked, can I use this point here? Yes. Okay, I could have used 0, 1 and gone from there. That one would have gave me the 2/3 before the 4/6. But if you notice, does it matter? So if you're given like 5 different points, does it matter the 2 points you choose to find your slope? No. Okay, you just need 2 of them. All right, and then looking at number 3, we have to use our formula. Okay, so again, it doesn't matter which point you guys use first. And I always label our ordered pairs are always what, comma, what? X and Y. So I make one of them 1s and I make the other ones the 2s or vice versa. It doesn't matter. Okay. Now, I'm going to plug it in, and I always plug them in with parentheses. Why? Because we have a subtraction sign, right? So what is my y2? What do I have labeled as y2? -3 minus y1, 4. x2, 2, and x1, 5, right? So what's a -3 minus 4? -7 over 2 minus 5, -3. And a negative over a negative is a positive. So we get a positive 7/3. Okay. All right. Now, example 2, to find the slope between the 2 points. So go ahead and work for it. You're welcome. I'll see you tomorrow. X1, Y1, X2, Y2. X1, X2, Y2. X1, X2, Y2. Let's look at the first one. What's my y2? 5 minus, what's my y1? -9 over x2. -2 minus x1. 5 minus a negative. 2 negatives make a positive. So what's 5 plus 9? 14 over. What's a -2 minus 7? -9. Can I simplify 14 over -9? No. So my slope for this one is 14 over -9. What's another way I could write that? -14 over 9 or -14, 9. So wherever you have the negative, it doesn't matter. You can only just have one, right? All right. Number 2, what's my y2? -4, y1, -4, x2, and x1. -4 minus a -4. 2 negatives make a positive. So what's a -4 plus 4? 0. -7 minus 3? -10. And 0 over anything is always 0, right? You rise 0. So isn't that a horizontal line? Yeah. Yeah. That's okay. So if you switch around the negative or the x1s and y1s around on x2s, that's fine. You'll just have a positive, but 0 divided by a positive or 0 divided by negative is still going to be. What happens when you're looking at, especially at this one, your 14 would be negative and your 9 would be positive if you switch. But isn't that still the same answer? Yeah. Okay. All right. And then the last one, what's my y2? 8, y1, 5, x2, and x1. 4. Okay. And again, as long as if you switch the 5 and 8 around, make sure you switch the 4 and the 3 around, right? So 8 minus 5 is 3. 3 minus 4, -1. And what does 3 over -1 simplify to? -3. So -3 is my answer. I would have accept 3 over -1 as well as -3 over a positive 1. But again, we can't simplify that. Okay. Any question on finding slope? Do you guys remember all of this from last year? Yeah. All right. Can you draw a line now with a given point and a slope? Yes. Remember, a point is a point on the graph. What does a slope actually mean? What does slope mean? change in y over the change in x, or rise over run. It's not an actual coordinate, is it? No, it's like the steepness of my line, right? So I can't graph slope until I graph the point, right? So can you graph the point of -2, 1? Yeah, so always graph the point first. Graph point first. So how do I graph -2, 1? How do I graph the point -2, 1? Go ahead. Yeah, I'm going to go left 2 and up 1. So that is point P right there, right? Now, from that, we're going to use our slope. And again, what is my slope? -3 over what? We always make it a fraction. So -3 over 1. So now my rise is negative. So am I going to go up or down? I'm going to go down 3 units. My run is a +1. So do I run left or run right? Run right. So from point P, I'm going to go down 3 units and right 1. So down 3. 1, 2, 3, right 1, and put a point. And then I'm going to do it again. I always want 3 points. Down 3, right 1. And now, can I draw a line with arrows? Yeah. Now, could I switch that? How could I switch going down 3 to the right 1? So if I ran out of room on my graph, how could I switch it? I could go up 3, meaning it's a positive. And then instead of going right 1, I could go left 1, meaning it's negative. Isn't a positive over negative still a negative? Yeah. Okay. All right, go ahead and try number 2. Go ahead and try number 2. How did you guys graph the point 5, -3? I'm going to go to the right 5 and down 3. So this is my point P here. Okay. Now, my slope is 1/2 and it's positive, right? So my rise is +1. So that means, am I going to go up or down? Up. So I'm going to go up 1, and my run is positive. So which direction will I go? To the right. So I'm going to go up 1, right 2. Uh-oh, I ran out of room. So how could I reverse that? I could go down 1, meaning -1, and I could go to the left 2, making it -2. Isn't a negative over a negative a positive still? Yeah, so I could go down 1, left 2, and I could go down 1, left 2. And then draw my line with arrows. And that is 8.3. Yes. Yeah, go ahead. All right, any questions with slope? And that's 8.3. Pretty basic, right? This is a lot better than chapter 6. Okay. All right, and then 8.4, the slope intercept of a linear equation. Slope intercept form. Who can tell me slope intercept form? See someone, Jackson. Yeah, y equals mx plus b. Where m represents the, everyone, what's m represent? Slope. And b represents the y-intercept. Yep, which means where it crosses the y-axis. The x and y in your equation is always there to represent all the points that are on that line, right? So if I give you this equation of y equals, let's say 2x plus 3, the x and y stay there because if I go, does the point 2, 7 lie on that line? Could you guys figure that out? Yeah, because a point is x comma y, we could plug it in, right? That's the reason why the x and y are always in there for you, okay? So now, to be able to find the slope and the y-intercept, every single equation needs to be in slope-intercept form, right? So looking at Example 3, okay, find the slope and y-intercept. And the reason why it's example 3, because 8.3 and 8.4 kind of really go together, so I wrote them together. So I never changed the examples. All right, can you find the slope of y equals 3x minus 1? Yeah, what is my slope? 3. What is my y-intercept? -4. Could anyone, you don't have to do this, but could anyone give me the y-intercept as a coordinate? What would the y-intercept be as a coordinate? 0, -4. Because remember, if it's a y-intercept, what is the x coordinate? Always 0, right? What about B? Y equals 6.5. What's my slope? Okay, hold on. What's my y-intercept? Let's do that. 6.5, right? Or 0, 6.5, right? Now, what are we missing? We're missing the x, right? What times x would eliminate the x? 0. So what is my slope? 0. Now, someone asked, when would it be undefined? Okay, when it's undefined, think about it. What kind of line is an undefined slope? It's a vertical line, right? And if it's a vertical line, what is the axis it crosses? X. What doesn't it cross? The y. So you will see like x equals 4. This one has no y, so actually this is a vertical line, right? So it's vertical, so the slope in this case would be undefined, right? And would we have a y-intercept? No, there is no y-intercept. We actually have an x-intercept, right? Okay. All right, what's wrong with C, D, and E now? They're not in slope-intercept form, but do we know how to solve for y? Yeah, so let's solve for y. How would I move that -5x to the other side? Couldn't I just add it? So I have -y equals, what's -2 plus 5x? Can I add those? No, so isn't that just 5x minus 2? And I always put the x first. And then y is still negative, so how do I get rid of that negative? Divide everything by -1, right? So we get y equals, what's 5x divided by -1? -5x. And what's a -2 over -1? Now can we find our slope? And what is my slope here? -5. And what's my y-intercept? 2, or 0, 2. What about D? Are we in y equals mx plus b form? No. So how do I move that x over? Drop it. So x minus x is 0, so we have a positive 4y now. What's -10 minus x? Isn't that just -x minus 10? Because I can't actually subtract those. And then how do I get rid of that coefficient of 4? Divide by 4, and I make sure I divide everything. So y equals, what number is with the x? -1. What's a -1 over 4? Isn't that just -1 over 4? A negative and a positive stays a negative. And what does 10 over 4 simplify to? 5 over 2. So now, can we find my slope? Yep, and what's my slope? -1/4. And what's my y-intercept? -5. Is this new to anybody, or is this all review for you guys? All review. All right, go ahead and do E on your own. Find my slope and my y-intercept for you. You guys at home doing okay? Is this all review for you guys as well?
Yeah.
Okay. I think this is a good break from what we've been doing this quarter. So what did you guys get for slope? -3/4. And what'd you guys get for your y-intercept? -3, yeah, because we subtracted the 3x over, right? So we have 4y equals -3x minus 12, and then divide the 4. So we get y equals -3/4 x minus 3. Good. Right. Now, graphing. Huh? For v? Yeah, you would put it at -2.5. And then from there, you would go down 1. So if you're at 2.5, -2.5, you go down 1, which puts you at -3.5, and then over 1. Okay. Now, usually, if I'm having you graph and slope intercept form, your y-intercept is going to be a whole number. Okay. If I was doing, honestly, if they're in standard form, once we get to this, I would find my x and y intercept and just graph those and draw your line. Yeah. All right. So graphing and slope intercept form. The first thing, can you guys identify the slope and the y-intercept? So exactly what we did. Then let me ask you, what would I graph next? Would I graph the slope or the y-intercept? Which one of these is a coordinate? The y-intercept. So you're going to graph the y-intercept. Just like we did with the point and the slope, we graph the point first, then use my slope. Here we're going to graph the point, which is the y-intercept, and then we will use our slope. So from the y-intercept, and remember the y-intercept is on the y-axis. And which one's the y-axis, guys? Up and down. Thank you. We're going to use our slope. And we remember our slope with rise over run. Rise, we go up or down. Run, we go left or right. I always do right or left. I say left or right, but I write right. Right. Now, example 4 says graph each linear function, then identify the x-intercept. Okay, so we have a couple things we have to do here, right? Now I'm going to show you 2 ways to find the x-intercept. Okay, so the first thing is, let's go ahead and graph this. Are we in slope-intercept form? Am I in slope-intercept form? Yeah. So what is my slope? 4 over 1, and my y-intercept is what? -4. And what is that as a coordinate? 0, -4. And the only reason why sometimes I put it as a coordinate is so you remember, a lot of times you guys could graph the point, right? 0, -4. A lot of people mess up the x and the y-intercepts, okay, when they actually graph it. So the y-intercept is on the y-axis. So I'm going to go down to -4. Then from that point, I need to rise over my run, right? My rise is positive. So which direction will I go? Up. My run is positive. So I'm going to go to the right. So from that, I'm going to go up 4, 1, 2, 3, 4, right 1. Then I'm going to go what? Up 1, 2, 3, 4, and right 1. And then I'm going to draw my line. Now, looking at this, okay, here's one way to find it. Looking at this, where does my line cross the x-axis? At 1, as a coordinate would be 1, 0. Good. The other way to find the x-intercept, if you don't know, plug 0 in for y, and can you solve for x? Yeah, so that's one way, is looking at the graph. That graph. The second way is to put 0 in for y and solve. And could you solve for x here? Yeah. How would I move the 4 over? Add it. And then how do I get rid of the 4? Divide it, so x equals 1. So that's the second way you can do that. Okay. Does it matter which way? No. Okay. All right, B. Are we in slope-intercept form here? Yeah, that's nice. So what's my slope? 1/2. And what's my y-intercept? 2, which is 0, 2. So again, what do I graph first? the y-intercept. So I'm going to go 0, 2. So on the y-axis, I'm going to put it point at 2. Okay. Now from 0, 2, I'm going to use my slope. My rise is a positive 1, so I'm going to go what? Up 1. My run is a positive 2, so I'm going to go to the right 2. So up 1, right 2. Up 1, right 2. Now, if I draw my line like that, would I cross the x-axis? Yes. If I draw my line, I'm still going to cross it because it keeps going. But do we know exactly where it's at? No. So could I go ahead and reverse this to get the point on the x-axis? Yes. How would I reverse going up and to the right? I could go down 1 and to the left 2. So from here, I'm going to go down 1, left 2. Am I still in line? Yes. Down 1, left 2. Now, can you guys see exactly where my x-intercept is? Yes. And where is my x-intercept here? At negative 1, 2, 3, and 4. There you go. Again, you could plug 0 in for x and solve, couldn't you? Right, C, are we in y equals mx plus b form? No. So how do I move that 2x over? So we have y equals negative 2x plus 2. Is y by itself now? So what is my slope here? What's my m? Negative 2 over 1. And what's my y-intercept? 2 or 0, 2. So how do I graph the point 0, 2? I'm going to go up 2, right? All right. Now, from there, let's use my slope. My rise is a negative 2. So what am I going to do? Go down 2. My run is positive, so I'm going to go to the right 1, right? So down 2, right 1. Down 2, right 1. Down 2, right 1. Did we cross the x-axis? Yes. So do I need to do any more points? Now, what is my x-intercept? Where did this cross the x-axis? 1, right? And that 1. Now, okay, real quick, guys. What I always make sure you guys do is my slope is negative, right? Is my line going down? Yes. Make sure you graph your slope correctly. Okay. If it's negative, make sure your line is going down. If it's positive, make sure it's going up. Okay. All right. Go ahead and graph D for me. Go ahead and graph D and E for me, actually. That's correct for you guys. All right. Graph D and E for me. So in D and E, both of these aren't y equals, right? So how do I solve for y in D? Subtract the 3x, yep. So y would equal a negative 3x minus 3, right? So what is my slope in this one? Negative 3 over 1. And what's my y-intercept? Negative 3 or 0 comma negative 3, right? So how do I graph 0, negative 3? Down negative 3, right? Now, my rise is negative 3, so which direction will I go? Down. And my run is positive, so I'm going to go to the right. So down 3, 1, 2, 3, right 1. I ran out of room, plus I didn't see the x-intercept. So how do I reverse that? Go up 3 and to the left 1. So up 3, 1, 2, 3, left 1. 1, 2, 3, left 1. Now did we cross the x-axis? Yes. And where did we cross the x-axis? Negative 1. Great. All right, E. How would I solve for y here? Subtract the x, yep. So I have 2y equals negative x plus 6, and then what? Divide by 2. What's a negative x divided by 2? Negative 1/2 x. And 6 divided by 2? 3. So what is my slope here? Negative 1/2, and I'm going to just keep it with the 1. And my y-intercept is 3 or 0, 3. So to graph 0, 3, I'm going to go up to 3. And now my rise is negative, so which direction will I go? Down. And my run is positive, so I'm going to go to the right. So down 1, right 2. Down 1, right 2. And I'm getting close to the x-axis, so I'm going to keep going. Down 1, right 2. Did we cross the x-axis? And my line's not that straight. Yeah, where do we cross the x-axis at? 6. My x-intercept is 6. Any questions with graphing? No, pretty straightforward. All right. Did you guys talk about parallel lines at all last year? Yeah, parallel and perpendicular. Okay. Good thing is today we're doing the parallel part. On Wednesday, you're doing the perpendicular. So it's like I said, it's one page. It's pretty basic on that. What are parallel lines? They are things that don't cross, lines that don't cross, right? So two lines in the same plane that never intersect. Okay, so they never intersect. All right, two distinct non-vertical lines. Okay, two distinct non-vertical, because all vertical lines are going to be parallel, but does vertical lines have slopes? No, so they're not functions. So we can never talk about like their slopes in this sense. So two distinct non-vertical lines are parallel, and the symbol for parallel is two sideward slashes. I'm going to use that just so you guys know. If you see the word for perpendicular on Wednesday, I use an upside down T. That's what perpendicular means. That's the symbol for it. Okay, so two distinct non-vertical lines are parallel if and only if they have the same slope. Okay, same slope. What can you guys tell me about their y-intercepts though? They're going to be different. Why do you think their y-intercepts are going to be different? Right, if they have the same slope, same y-intercept, aren't they the exact same line? Then they wouldn't be parallel, would they? Because every point would be in common, correct? So parallel lines, same slope, different y-intercepts. No matter what, even though vertical lines are functions, they're still going to be parallel to what? Vertical line. So all vertical lines are parallel to each other, right? Even though they don't have a slope, they're undefined, they're still going to be parallel to each other, right? Okay. All right, show that the lines whose equations are given are parallel. Well, how are we going to show that they're parallel? We have to put them in what form? Slope intercept, so y equals mx plus b form. And then how would we tell that they're parallel? same slope and their y-intercepts have to be different. So we have to put into y equals mx plus b and show what your slopes and your y-intercepts are, okay? So 2x plus y equals 8. How do I solve for y there? Subtract the 2x to the other side. So we get y equals negative 2x plus 8. Is y solved for that one? Yeah, so what is my slope in this one? Negative 2. And if you put it over 1, that's fine. And what's my y-intercept? 8. Okay. So then we look at the second one. How do I solve for y here? Subtract the 2x again, right? So we get y equals negative 2x plus 6. So what's my slope? Negative 2 and negative 2 over 1, however you want to write it. And what's my y-intercept on this one? 6. So what do we notice? They have the same slope, same n, but different y-intercept, different b. That's fine. And you guys just showed that. Okay. Do you guys think you could do it for b? Yeah, go ahead and do that. Go ahead and put that into y equals mx plus b for both of those. If I solve for y in the first one, how do I move that 4x over? Subtract it. And when I subtract the 4x, I'm still left with a negative y because it was minus y. 1 minus 4x is just a negative 4x and a positive 1. And then how do I get rid of this negative 1? Divide it. So I get y equals a negative 4 divided by a negative 1 is positive. And 1 divided by negative 1 is negative 1. So what is my slope in this one? 4, and my y-intercept is negative 1. Okay. Looking at the second one, solving for 2y. How do I take the negative 8x over? Add it. Why? Because it's negative. So we have 2y. 2 plus 8x is just 8x and a positive 2. And then how do I get rid of that 2? Divide by 2, and I make sure I divide everything. So y would equal 8x divided by 2 is 4x, and 2 divided by 2 is 1. So what is my slope on this one? 4, and what's my y-intercept? 1. So do they have the same slope? Yes. Do they have different y-intercepts? Yes. Are they parallel? Yes. All right. Any questions? All right. Huh? All right. So